just throughout my college career. I've really loved going to Santa Monica Bay. It's one of my favorite places. I try and get out there whenever I can. Yeah, it's really beautiful, and I don't know, I'm glad to be a part of a project that can kind of potentially help preserve that and let people keep using that area.
So I was interested in joining the Bay Foundation project because researching an ecological approach to restore the coastal ecosystem in the Santa Monica Bay was really interesting to me and seemed like a project for a regenerative, sustainable future of the coast.
Our project was working with the Bay Foundation to see if eelgrass or other marine life can mitigate ocean acidification locally.
As part of that, we were trying to find out how the seagrass could modulate the pH of the environment immediately surrounding it. And so in order to test that, we developed this kind of probe structure.
The way that the probe rig is set up is it's made all out of PVC pipe and rope, and so we used a cube on the top that has zip ties that go into the corners to hold the probe in the center of this cube. And then there's also a 1/2 meter by 1/2 meter quadrat that's below the cube connected by rope. The reason we did that is so that you could lower down the probe and have the quadrat right beneath the GoPro and the probe that does the pH readings. You could get down, see the percentage of coverage of eelgrass on the seafloor, then go down, take your pH measurement, and then pull the whole rig back up. So it was a way that we could both see what we were sampling and also get a sample as close to the seagrass as possible.
And unfortunately, there was a lot of problems with this experimental setup. It was really difficult for us to actually find the eelgrass, and we weren't able to see where we were lowering the probe. So sometimes we lower it and then we pull it back up and we look at the camera and it's just sand on there that we were looking at.
And when we started to look for eelgrass, there was none in the bay, as we thought there was. Considering the big problem of ocean acidification and the fact that there is no primary producers to be able to sequester carbon out of the ocean, you can see how it's an even bigger problem than we first thought.
It almost felt like we were failing at our project, but the Bay Foundation's work of restoration is even more important now that we know that it's an even bigger problem than we originally realized. The density of the eelgrass isn't anywhere near what we thought it would be. We thought that we would be studying these really lush meadows, and it turns out to be pretty patchy and not very dense at all. So it's really hard to quantify the effects of eelgrass and how it modulates pH. So we started looking at El Pescador, El Matador, Lechuza, but then we went to Amarillo with the Bay Foundation, and that site was the best to meet our needs because it actually had seagrass that we could find there.
My favorite part of this project was finding actual seagrass beds in a site that we were not originally interested in. And so when we found it, everybody was really excited because there was seagrass. So it shows that our project was going on the right path.
We went out with our client, the Bay Foundation, and it was a pretty long day, but we basically got on the water at probably 7 a.m.
Being out on that boat can be pretty rough and choppy at times.
We are very, very cold. It's okay. That was the first time that we used a Niskin bottle to collect our water samples so that we could have water from right above the seagrass where we were taking our probe samples. We collected pH readings, water for environmental DNA analysis, nutrient analysis, and the carbonate system analysis.
So with the in situ probe, we collected a lot of chemistry data, which included pH values, dissolved oxygen, temperature, salinity, air temperature, and many different parameters of the seawater. And we analyzed these basically comparing different categorical groups of eelgrass density, seafloor depth with each other, and comparing the dissolved oxygen, the pH to each other, and then comparing some of the pH and dissolved oxygen to the other physical parameters, including temperature and salinity. And comparing them allowed us to estimate the contribution to pH from biological sources or more physical sources. For example, a high pH to dissolved oxygen concentration suggests that organisms that are photosynthesizing and respiring contribute to these pH and dissolved oxygen values.
We got some decent data. We weren't able to find a statistically significant correlation between the presence of the seagrass and a change in the pH as a result. But what we did collect that I think is going to be really helpful for next year's group is some really good data on the environmental DNA. So what are the organisms that live in those seagrass communities? That's something that next year's group can analyze, as well as the nutrient levels and the carbonate chemistry of those seagrass communities. And I think that's data that they can analyze that'll help the Bay Foundation decide where a transplantation site would be most suitable for their project.